The Stone Age. So why do we actually call it the Stone Age? Well, you might say because back then people relied mainly on tools made of stone. No, I don't think so. It's certainly not what we're seeing here. Okay, maybe these guys are actually using stone tools. The rest of the community, they're using tools and equipment mainly made of all kinds of other materials. I think we use the term Stone Age because stone tools are generally all we have left from that time. But actually they had a lot of other materials for making their gear. They had bone from the animals they hunted, and antlers, and skins, and you can even make tools from mussel shells. And then of course there are plant materials, wood and bark from various trees, and roots and stems useful for basketry, as well as fibers you can get by processing various plants. But on so many Stone Age archaeological sites, none of these are actually preserved. Once they become buried in the ground, all of these materials decay. On some Stone Age archaeological sites, you find at least bone and antler, but where the soils are acid, even these will have been dissolved. Whereas stone tools, they basically last forever. Of course, archaeologists want to get the full picture of life in those times. But how can we do that when so much has simply vanished? Well, there are some archaeological sites that do have amazing preservation, sites where a lot of material has remained undecayed because it stayed wet ever since the Stone Age, such as this site, Saarnate, at the edge of a peat bog in the west of Latvia. When the site was excavated, starting in 1939, it produced a whole range of artifacts of wood and bark, as well as remains of house structures, giving a fantastic insight into life as it was here 5,000 years ago. But in general, we have this situation. Out of necessity, Stone Age archaeologists have become really good at studying stone tools to extract the maximum information about those ancient people. But then something happens which is a real boon for the archaeologist. People start making pottery. They first did it as long as 20,000 years ago in the Far East, in eastern China and Japan. They started shaping pots from clay and firing them. This innovation spread across Eurasia. It took millennia, but around 7,000 years ago, the technology of pottery making also reached this part of Northern Europe. And fired clay, too, is a material that preserves really well, although we usually find the pottery vessels broken into fragments. For me, pottery is a very special material. The thing is, pottery surfaces also preserve traces of the different objects that came into contact with them before the pots were fired. And this includes the kinds of objects we generally don't find because they've completely decayed. Essentially, it's a way of studying things that no longer exist just by examining the traces they've left. From the Saarnate wetland site, for example, we have almost no bone because it's been dissolved in the acid conditions of the bog. But we do have this. It's pottery decorated by imprinting it with the teeth and jaw of a sea mammal, a porpoise. We know these people were hunting porpoises, and the only reason we know that is because they were decorating their pottery with these very distinctive marks made with porpoise teeth. And this is where slanting light comes into it. What I use to study features preserved in pottery surfaces is a method called reflectance transformation imaging. You take a series of photos of the object, keeping the object and the camera still, and only changing the light direction. And then the software compiles a kind of virtual model, where you can manipulate the lighting direction to reveal all the surface details. Now, the ancient hunters and fishers in this part of Europe used a variety of objects to imprint their pottery. Not just porpoise teeth, but also distinctive bones from animals that they hunted for their furs. But then something happens which I see as a big change in pottery decoration across Europe. At around 6,000 to 5,000 years ago, people in different parts of Europe, both hunters and farmers, started decorating their pottery with imprints of cord. A lot of the earliest cord decoration was made by winding a piece of cord onto some kind of firm support, and then impressing this special stamp in the clay. And we have plenty of it here, on the eastern shore of the Baltic. And this is a fantastic opportunity for archaeologists. As we saw, organic artifacts such as cords and other textiles are very rarely preserved from the Stone Age. And so the imprints in pottery are crucially important because they give us a unique window into this technology. In a way, it's not really surprising they chose to decorate their pottery with cord, considering that cords and ropes were such an essential part of everyday life. But there's one kind of equipment that needs a great deal of cord. Fish nets. Fishermen in recent times have been using vast amounts of cord for their nets. And this is not something new. We know from archaeological finds that fish nets have been used in the Baltic Sea region for at least 10,000 years. Back then, they didn't have cultivated plants such as flax to provide the fiber for cords. But fiber could be obtained from the inner bark of trees, especially the lime tree. You strip the bark from the tree or from cut branches. Then you soak it for some weeks. Finally, you get this material, tree bast. Tree bast is excellent for twisting into cords and ropes. Here I'm using the finger twisting method to make a cord from 2 strips of lime bast. I take one of the strips and twist it one direction, and then with my other hand I pinch it together so that it doesn't unravel. I'm actually twisting twice over to give a really tight twist, and then I twist both strips together in the opposite direction. It's quite slow, but in this way I get a really tightly twisted cord. We know from some finds of cord preserved on the Saarnatte bog site that this is precisely the kind of cord they used. But these are indeed very rare finds. Whereas pottery is superabundant in museum archaeological collections in all of Europe. And so for tracing the practices and technologies of ancient cord making, we want to maximize the information we can extract from imprints in pottery. And this is what some researchers, including myself, have been doing. From the imprints we can assess the thickness of the cord, how tightly it's been twisted, and the direction of twist. In other words, we're getting the essential technical data on artifacts that simply haven't survived, and through this we can trace ancient fiberworking traditions. But the imprints in pottery aren't restricted to simple cordage. Look at the very shallow imprints on the rim of this potsherd. They've been made with some kind of interlaced material, but it's not a cord. The pattern is more like a plate. This is the kind of thing I've been looking at now. We find these imprints on pottery especially from the west of Latvia and Lithuania in the 4th millennium BC. We call them plate imprints, but nobody really knows what technique was used to make the stamps. The only actual surviving object that I can see could have been used to make such imprints is this tiny piece of birch bark plate, once again from the Saarnatte site. Is it something like this that's been used to make the imprints? It's certainly a very unusual technique that's been used to make this piece. In northern countries with plenty of birch trees, birch bark has of course been used a lot for various purposes. This includes a big tradition of plating together strips of birch bark to make containers. Actually, I don't understand precisely how this piece has been made, but it's evidently a kind of knotting technique. I found it's possible to make a knotted plate of 2 birch bark strips in a similar way to the plates people make nowadays from ribbons. When you imprint it in clay, it looks like this. It gives a kind of stepped pattern, which is not a match for the imprints we see in the pottery. So I turn to another material, rushes, and another technique. This is one more material that would have been readily available to Stone Age hunter fishers in their typical lakeshore environment. Rushes, when you interlace them, behave very differently to birch bark. They're no good for knotting because when you bend them they make a sharp angle. Instead, what you can do with them is make the kinds of plating they do with straw, which involves folding the strips. This is what they call fill the gap plating. You fold each strip over the others in turn. And you get this kind of helical form. And this is what you see when you imprint it. Once again, it's a little similar to the imprints in our pottery, but not sufficiently close. Actually, I went on to make a whole series of different plates from bast and birch bark and rushes. But even though the imprints in pottery are very indistinct, I can see that none of my experimental plates correspond to what we see on the pots. So it's still a mystery. There's some special technique of interlacing strips of material that was used in this region in the Stone Age, which I can't yet reconstruct. Of course, it doesn't help that the imprints in pottery are so very shallow and indistinct. And it makes me wonder why they decorated pots with imprints that are so shallow they can hardly be seen. But I can think of one possible explanation. Maybe the imprints were not really intended to be viewed by daylight. This needs one more little experiment, this time using a replica Stone Age pot made by my colleague, potter and pottery researcher Baiba Dumpe. These pots were made to be used for cooking, where you stand the pot in soft ground and build the fire around it. I guess you get the idea. Slanting light once again.